So as we start to look at code, what we're really looking for is, why does this diverge from best practices? Why is it not running efficiently? If it's not maintainable, why is it not maintainable? Because if I'm done with the stored procedure and I'm rewriting it, I want to make sure that the next person who steps into this can easily figure out what it is I'm doing, what I was trying to accomplish, what it was I was, what I'm doing, where I'm going with it, etc. So I'm going to go through two case studies. First case study is a piece of code that I wrote myself badly, and at the time that I was writing the code, I was doing this evenings. I had a client that I was working for evenings. I was teaching a class during the day, and so my schedule was teach class pretty much from 9 to 5, get back to my office, have some dinner, or I'd rather get back to my hotel room, have some dinner. From 6:30 to about 8:30, I would be responding to email, and then maybe at 9 o'clock, I would start writing code until maybe 1 or 2. So these are very busy days, and by Wednesday I was kind of tired. But the task that I was trying to do here was we were doing a migration. The customer had disparate data spread across a bunch of access databases, and we were moving it into SQL Server for them. The task here was made more difficult by the fact they didn't have consistent keys. They had a lot of data that needed to be cleaned up. Their data did not have a lot of consistency. So, for example, we might actually have 2 rows that were identical, but both rows were valid. So I'm donating $50 to this cause. Oh, now I'm donating another $50 to this cause because they talked me out of another $50. But that's 2 entries. That's not one for reporting purposes back to the government, the other. So I took this and I wrote it, and it ran in a few minutes. And it really doesn't matter. This is migration code. Nobody's ever going to look at it but me. But after I wrote it, I looked at this and I said, I'm teaching people how to write good SQL code, and here I wrote this absolute junk. I can't do this. I'm going to rewrite it. So I took a few minutes and I rewrote it, and it went from several minutes down to a few seconds. I was very happy, and the next morning I brought it in and I said, okay, folks, I've been making fun of bad code for the last couple of days, and now I'm going to invite you to make fun of my bad code. And I went through the bad code that I wrote, and then I went through the code that I had just written. And remember, I was finishing this up at 2 in the morning. And by the time I was done, I realized that there was a much faster way of doing what I had just done, which was taking it down to 1 second from several seconds. And at that point, I quizzed the students, and I said, okay, folks, now that I'm more awake and I've had 6 hours of sleep, there's a better way of doing this. What's the way? And the class came up with it. It's relatively simple. So what we're going to do here is we're going to take a look at an example, and we see things like this all the time. We're going to make fun of the first example. We're going to look at the rewrite. Then we're going to make fun of the rewrite, and then look at a final solution. Now, what we've got here first is the very bad code, and what we have really is the need to create a header-detail relationship. This says cost sheet header and cost sheet detail. Think of it as an invoice header, invoice detail, or whatever other header detail type of relationship you need to put together. It really is the same thing. So what I have to do in this case, I have the headers, and what I need to be able to do is say, okay, now I need to take the detail information. For each of the detail information, what I'm going to need to do is come up with new header IDs for that detail information. How am I going to number these? Well, at 1 in the morning, the ideal way of numbering these things seemed to be an identity column. So I created the identity column, I inserted all the information that I wanted, and then I worked on it. Now, I also created a second temp table. The reason I created the second temp table is because I wanted to be able to modify those identity numbers. Guess what? If it's an identity column, you can't modify it. As a result, I spent some amount of time at 1 in the morning trying to figure out how to get the numbering and then remove the identity attribute. Well, that didn't work, so eventually I said, I'm working too hard with this. Let's just create a second temp table, and we'll insert everything from that first temp table into the second temp table. This second temp table is something that I can manipulate. So I'm inserting into the first temp table the result of, it was actually a little bit more complex with this. We had to do a lot of cleanup. We needed to make sure that the things that we were looking for existed, and we did put the sort in there. So the original activity here was very relevant. Get the headers and line everything up. Now, the second thing we did with this was to insert from that particular temp table into the new temp table. Now, the one intelligent thing that I did was to create a clustered index. If you're not indexing your temp tables, you're probably missing out on a trick. If you're only going to modify or access the temp table once, probably doesn't make any difference. But if you're accessing a temp table multiple times, it's probably cheaper to create the index on the temp table than to do all the hash joins into the temp table. This is something that you can experiment with, set statistics IO on, find out what the cost is doing it each way, and go for it from there. So on that second table, the table I was going to manipulate, I created the index, and now I create a loop. Get ready to make fun of my code. While I have rows in that cost sheet temp table, this was what I'm doing. I'm inserting rows into the permanent table. So here's what happens. I have header 1, and then I have header 1, header 1, header 1, and then detail 1, detail 2, detail 3. What I want to do is get all the rows for that header 1, the course, and put those in there first. Then get rid of it. So for header 1, I may have 1, 2, 3, 4, and 5 in terms of the details. I'm bringing those out, putting them into the temp table. Now, the second thing I'm doing is deleting the rows from the temp table. I'm getting rid of those 5 pieces of information that I put into the permanent table. Now I've got header 2, maybe 5 of those, but they're numbered from 6 through 10. I don't want them numbered from 6 through 10. I want them numbered 1 through 5. So what am I doing? I'm updating the temp table, and once the temp table is updated, what I'm doing, part of the updated temp table is I'm changing all of those sequence numbers to be 1 through end of the table instead of 6 through end of the table. How am I doing that? I'm getting the minimum sequence number. So if the minimum sequence number is 6, 6 minus 6 is 0, add 1, the first one is 1. The second one is 7. 7 minus 6 is 1, add 1 is 2. So everything gets numbered properly. Then I go through this for every single header in the database. This is really ugly. What am I doing? I'm using multiple temp tables. I'm performing lots and lots of deletes. I'm performing lots of full table updates. This is going to crush TempDB. It's really going to crush the log, and anybody else who wants to do anything along at the same time is going to get upset. The only thing that makes this not take days and days and days was that index that I put out there, but still, this activity for a relatively small amount of data, there was only a few 100,000 rows of data, was up in the 8 or 9 minute range. Now, when you're writing this type of code, 8 or 9 minutes during a data migration probably doesn't seem like a lot, but a data migration implies that the system is coming down while you're moving from one system to the other, and as a result, what you're going to want to do with that is minimize it so that your downtime is reduced. So, multiple temp tables, huge I/O, huge updates, many passes through the temp table, very, very ugly. So after doing that and making fun of myself, I said, you know what? There's an easier way to do this. I can do this with a single pass through the temp table. As I'm running through this, I'm inserting, I'm still getting all those identity values in the sequence number. But instead of creating a separate table, I'm creating the clustered index right here on that original work table. So now what I have is invoice 1, detail 1, invoice 1, detail 2, etc. Then I have invoice 2, detail 6, invoice 2, detail 7, etc. And so everything is still the same in the original table. But now, this is 2 in the morning clever. 2 in the morning clever says, let's do a self-join. What I'm doing here is selecting do the insert select, but the insert select is selecting into the header ID, or the new table header ID, the sequence number minus the min sequence number plus 1. What's the min sequence number? Well, what I've done down here below is to create a derived table that has the minimum sequence number for each of the cost sheets. And I'm joining to it. So what does that do for me? Oops. So what is that doing for me? What that's doing for me is giving me the ability to say, okay, for cost sheet header 2, the sequence number, first sequence number is 7. 7 minus the minimum sequence number of 7 plus 1 is 1. The second one is 8. 8 minus 7 plus 1 is 2. So what I'm doing here is inserting everything. I'm doing a single join. This was actually pretty fast. This ran in just a couple of seconds. I inserted into the temp table. I put the index on the temp table, and then I did the insert select. Derived tables are very cool. Hopefully you're not deriving lots of tables. Joining to that derived table was not hugely expensive, as the derived table was small. The select brought the data back relatively quickly. And I went to bed happy that I'd done something good. Now, as I was presenting this to my class in the morning with all of the this is why it's bad, and this is why I did it, and this is what you look for, and this is where we're at, it occurred to me that we could do it all at once with no temp table. And after sitting through the class, everybody else agreed with me. Here's what you do. In a single select statement, rather than having the sequence number occur the way we described it, we say number the rows. Add a row number. Row number function is new for around SQL 2005. What it allows you to do is either number the entire table or number it across a value. Here I'm saying partition it by header ID. Now, because we're partitioning it, numbering it by something, we have to do an order by. The order by didn't matter to me. I just picked a column at random, but this ran in about a second. This was extremely fast, very efficient, takes advantage of the functions, avoids tempdb, no joining, no indexes, no you name it. Very good stuff, very efficient, and the lesson learned there is I can write bad code too. I do know the difference, and I can point to it and laugh.